Hello, my name is Ben Gregory, and I am going to walk you through a tutorial on how to use Altair's Inspire Extrude Metal. So we can click the Start button and launch Inspire Extrude Metal 2019 version 2. Once the software is launched, we can open our CAD. I have a Parasolid file right here. Also, step files work well with the software. So we'll import that CAD. The best way to have your CAD is in an assembly. In this case, we would like a die, a bolster, and a mandrel all assembled together. You only need the die though. We will start by orienting our assembly. We'd like the material to be coming out in the positive Z direction. In this case, the assembly is properly oriented. If it's not, you would click the Orient button, click the die exit surface, and it would orient it for you. Now we'd like to extract the flow volume. We do this by selecting the whole assembly, hitting flow volume, and letting the software extract the flow volume. This is empty space between the mandrel and the die. We don't want it here, so we can either hit the delete button or we can hit delete. Now we'll select the bearing surface. By doing this, we do not hit this H, but we hit the disc behind it. And then we click the surface at which our bearing will come off of. The software automatically creates two bearing curves. If this menu is not up, click View and Model Browser, or F2. We now see bearing curve 1 and bearing curve 2. The bearing is also created and the profile. We will leave these all at their default. We would now like to create a pocket and the portholes, so we hit the Organize button. And if we zoom out, we see that this whole thing is a flow volume right now. We'd like to split it into the pocket and portholes, so we click on the top surface, and we click this button. We click the Z and we drag it down. I like 10 millimeters because there's no complex CAD anywhere here. It's an easy surface to cut. You hit cut. Now we can exit out of this menu. So now we have two flow volumes. We can make this flow volume a pocket by right-clicking, hitting Organize As, Pocket 1. This flow volume we can right-click and hit Organize As. And we want those as portholes. So now our flow volume is properly set up. We can add a billet by hitting Billet. Our billet diameter for Michigan Tex Press is 3.5 inches, or 88.9 millimeters. The container diameter for Michigan Tex Press is 3.7 inches, or 93.98 millimeters. And the maximum billet length in Michigan Tex Press is 10 inches, or 254 millimeters. We're going to go with no skin thickness, as that makes the computation much longer. If you'd like to, though, you could add in skin thickness at this point. Next we're going, or not yet, select our materials. We're going to add boundary conditions on the bolster so that the software will take into account deformation of the bolster, die, and mandrel during its calculations. By doing this, we show all three pieces. Once all three pieces are visible, we click on Tool Deflection up here, and we click on BCs, these little feet below, and we click on the side of the bolster. That's applied the boundary condition to the side of the bolster. We click the feet again to exit out of the menu, and we right-click on the bolster, organize it as a bolster, organize the die as a die, and organize the mandrel as a mandrel. Now we can go back to the extrusion menu, and we can look at our materials. So we have to select three materials: a workpiece, a coolant, and a default tool, and a tool material. For the workpiece material, let's do 6063 aluminum. So I right-click and I click Select, and now we see that that's been selected. I can click on this folder and now go to Tool Material. All of Thumb Tools materials are H13 tool steel, so I will select that. I'll also go to Coolant, and we will select the default coolant. Click OK. Now our materials are selected. Next is Press Data. If this is your first time using the software, you'll want to go to File, Preferences, Databases, and set your press database to somewhere other than the C drive. For me, I've set it to the H drive and in a folder called Inspire Extrude Press Data. Select the folder, click Apply, and click OK. Now here's my user database in that folder. I've created a press by clicking this button, which lets you add a press. I'm using Michigan Text Press. You would enter in all of this information. Michigan Text Press has a 60-second dead cycle time as an approximation. However, we are running one transient analysis with no cycles. We don't want it to calculate 60 seconds before or after, which it would do if we had a 60-second dead cycle time. So to save time, we have 0 seconds entered as our dead cycle time. Click OK there. And now to the variable time step data. This billet length is calculated automatically based off of the previously entered billet length. You do have to change the butt length. We do 50% of the full billet length. Sorry, 15% of the full billet length. So 15% of 254 is 38.1 millimeters. The RAM speed we have as 10 inches per second, which would be 4.23 millimeters. Sorry, 10 inches per minute, which would be 4.23 millimeters per second. We will keep the default RAM acceleration time. Now if you are going to do a transient analysis, you go to a manual time step, and you can change all of these factors. For us, we care a lot about the maximum pressure, so between 0 and 5 seconds where that maximum pressure will likely be hit, I'm going to up the number of time steps to 10 steps at a step size of 0.5 seconds to give us a better chance at accurately catching the maximum pressure. We don't really care what goes on after that, so I'm going to lower these to 2 seconds to decrease the time it takes to run the analysis. Click Apply and OK. Next up is the billet taper. We have no taper, so we are going to set this at 0°C. Our preheat temperature can be whatever we want, in this case 425°C. The RAM speed you have to re-enter again, and that will be 4.23 millimeters per second. And the billet length was again calculated automatically by the software. You hit Apply and OK. Now we're ready to run the analysis. We click this button. The RAM speed is correct this time, but guess what? The billet preheat temperature did not update, so we will make that 425. So this brings up an important point that these two variables, RAM speed and billet preheat, have to be consistent across these three menus. So make sure that they are consistent because they don't always update. Next, the die temperature. Michigan Tech usually does 425°C and 425°C for the container temperature as well. Mesh size controls how nice of an analysis you're going to do, but also how long it will take. So you'll get a better analysis, but it will take longer with a fine mesh. You'll get a less accurate analysis, but it will take a lot shorter with a coarse mesh. We have a direct press. We'd like transient flow so that we can calculate different time steps. If it was steady state flow, it'll approximate the entire extrusion as one steady state process, which does not get the nice pressure spike at the start before breakthrough has occurred. So, in my opinion, steady state is pretty useless. You always want to use transient, but transient does take longer. All of these other defaults are good, and we click Run. Now a menu opens showing the status of our run. This run will probably take 2 hours to analyze. Once the calculation is complete, you can go to the Run options, and this will show you the file path and where all of the information for the run is stored. If I open this, this is run 02, and right now we have nothing in the folder, but as the run happens, more and more files will be populated. Once the run is complete, you click on this H, and it allows you to see temperature during each of the time steps, pressure at each of the time steps, and other things such as grain size, relative exit velocity, and so on. Also within this folder is a .stat file, .stat. That is just a text document that you can open up and get specific numbers for the maximum pressure and maximum temperature during each time step. So that can be incredibly useful.